Hello everyone, welcome back to our virtual lessons for intensive physics. We're going to continue chapter 20 and our practice problems from last time. If you feel confused on any of the following problems, I'd recommend that you go back and watch our first video of practice problems where I go into a little bit more detail on how to begin solving. Our first problem states that there are two spheres and they're 18 centimeters apart. One has a charge of 8 microcoulombs, the other has a charge that is unknown. If the force between them is 150 newtons and is directed away from each other, what is the unknown charge of the other sphere? Well, in word problems like these, I'm actually going to go ahead and draw a picture at the top. This isn't required, but it may come in handy if you're having some difficulty. So I know that there's two spheres. And I know that they're 18 centimeters apart. Okay? One has a charge of 8 microcoulombs. All right? And that's going to be a positive charge because that's positive 8 microcoulombs. Okay? But the other one is unknown. So we don't really know what that is. If the force between them is 150 newtons and is directed away from each other, okay, so our forces are going to pull these away from each other, we want to know what the unknown charge is in this other sphere. Now, remember that opposites attract. So if our forces are pulling these away from each other, we have to know that this charge is positive or negative. It's going to be positive, right? Opposites attract. Things that are similar repel. Let me redraw that. There we go. Okay, so we have two positive charges, but we don't know what the magnitude of the charges on this particular sphere. Okay? I'm going to write some of my knowns up here. Okay, so of course, my R value is 18 centimeters. Okay. My charge that I know, charge 1, is going to be 8.0 microcoulombs. Okay, and the force between them is going to be 150 newtons. And we're looking for, what's that second charge? Okay, we can go ahead and get rid of that so we have room to work. And remember from last time, in order for me to insert these into the equation, and I'll write the equation now. In order for me to substitute these in, I have to get it to my base units. And so right now I have a measurement that's in centimeters, but I can go ahead and use my calculator quick and convert that this is actually equal to 0.18 meters, okay? 18 centimeters is fine, but in order to plug this into that variable, I have to get it in terms of meters. All right, and we kind of do the same thing. We've got microcoulombs here, and so we actually can write that this is equal to 8 times 10 to the negative 6 coulombs. Okay, so we're going from microcoulombs to coulombs. All right, and our force is in newtons. That's completely fine. Okay, so I'm looking here, and I think we have enough to go ahead and start plugging into this equation. So our force is 150 newtons. K is still going to be our constant. That's going to be 9 times 10 to the 9th. Q1 is going to be 8 times 10 to the negative 6 coulombs. I don't know Q2, so I'll just put in a variable for that. And then my R value, which is 0.18, and I take that whole value and I square it. It's going to be in meters. Okay? So now what I want to do is I can multiply this value to the 150 and then divide what's on the left by our 9 times 10 to the 9th and the 8 times 10 to the negative 6 away. And when we solve for Q2, we get a value of 6, let me make sure I have this right, 6.75 times 10 to the negative 5 coulombs. Now, this would be an acceptable answer, okay? If you really wanted to get fancy with it, what you can actually do is you can write it as 67.5. This actually converts to microcoulombs. Okay, so either answer is completely fine. If I ask for it specifically in microcoulombs, then of course you need to make that conversion. If not, this is completely fine as well. Okay, let's erase the board and we're going to move on to our next problem. Okay, two spheres are an unknown distance apart. One has a charge of 5 microcoulombs and the other has a charge of negative 2 microcoulombs. If the force between them is 70 newtons, what is the distance between the spheres? So I'm going to go ahead and draw a picture. Again, this is not required, but it may help you solve the problem. I have two spheres. Okay, one is positive, this one's 5 microcoulombs. And then somewhere over here I have a negative, and the value of that one is negative 2 microcoulombs. Okay, and we know that there's a force between them of 70 newtons. Okay, but we want to know what the distance between them is. Okay, so we don't know what r is. We have to solve for it. Okay, I'm going to continue by writing my knowns on the left-hand side here. Okay, Q2 is going to be negative 2 microcoulombs. Okay, and the force between them is 70 newtons. Okay. Well, I think I've extracted enough data from the problem to go ahead and get started. So I guess the next thing I can do is I can draw out my equation. Okay, I'll fix this Q because it kind of looks like an A. Okay, now don't forget, in order for us to put it in terms for the equation, we need to go down to our base equation. So right now we're in microcoulombs, okay? And so we need to write this out as 5 times 10 to the negative 6 coulombs. And this one is going to be equal to negative 2 times 10 to the negative 6 coulombs, okay? And again, that's just because we're converting microcoulombs to coulombs. It's not always going to be 10 to the negative 6, but because it's microcoulombs, that's how we perform that conversion. My 70 is in newtons, so I think we can proceed with that. If we look here, we can start substituting. Remember, K is the same constant as last time. R squared, and I made a small mistake. We know what F is. 70 newtons. Okay, and so what we actually do here, we rearrange our equation and we solve for R. Okay, and so when we go ahead and we solve for R, we get 0.036 meters, which again would be an acceptable answer. But if I wanted it in centimeters, we can move that decimal place and write that r is equal to 3.6 centimeters. And I'm just gonna check that with my calculator because I don't want to make sure I didn't miss the square root there. Always double check your work if you can. And I think I will agree with my answer. Our answer is r is equal to 0.036 meters, or r is equal to 3.6 centimeters. As always, if you have any questions, please take a look at the shared Google Doc. If I don't get back to you right away, feel free to send me an email or take a look at your book if you have more questions. Thank you, guys.